Okay, welcome to this final video on the recitation of optimization using spreadsheets for advanced network design, where we are going to analyze a couple of results obtained in the last few parts of the foot on wheels problem. What I want you to do is to read through the numbers that you have obtained. Probably if you went through all the questions in part 4 and also in part 3 of this problem, you notice that we are still renting hub 5 and that we're still sending 101 units from that and to that hub. But at the same time, you probably notice that the transportation time, the total minimum one, is different. And that could also be related to the fact that we forced the model to satisfy a level of service policy. The first thing I want you to keep in your mind whenever you adjust or add a new constraint to a model is that if you're having the same exact model, just adding one additional constraint, so we, as we did here in part 4, right? Still 6 have still the same constraint of only one of those being rented, still the same capacities and demands. The only thing that has changed here is that now we have one additional constraint on the exact same model. Then there's no way I'm having a better result. How do we translate that into numbers? So one option is that we could have had the same transportation time. Another option, and it's what actually happened, is that I'm getting a worst solution, which means a higher transportation time. Since I'm trying to minimize, a worst solution means a higher time in this case. But in the case of maximizing profit, for example, it would be receiving the exact same profit or a lower one, because that would mean a worst result in that case. So this is a general knowledge I want you to keep in mind. I know you have seen that in the lectures already, but sometimes we miss out those important details. And I want you to analyze that every time you adjust a model. Are you getting a better result? Is that because you actually changed your model? Or is it because you made a mistake and you need to debug your model? Keep that in mind when solving your practice problems and graded assignments and, of course, exam questions. The next element I want you to consider is understanding what changed. Because if I'm still renting hub 5 and I still have 101 units, why do I have a higher time? And that's because we changed the flow within the total network. That specific flow from that specific rented hub did not change. But if you check possibly the flows from hub 1, 2, and 3, there may have been a change. And we also need to see if it changed only on the outbound, because that's where we added the constraint, but also did it change on the inbound? Because remember that any units flowing out of a hub should have been an inflow at the very first time. So if anything changed in the outbound flow, did it also adjust the inbound flow? So you can see here that the outbound time is 1,900, and in the past it was above the 2,000, and the inbound time in the past was below the 2,000 and now is above it. That's because whenever we change anything on one of the flows, as we connected them because of the conservation of flow constraint, we're also affecting the inbound one. Okay, so keep that in mind. It's very important that you understand what happened and why with any changes you implemented in your model. I also encourage you to analyze whether there's a different way of doing things. In this case, for implementing the level of service policy, we did calculate a rate because we made total demand complying with the level of service policies divided by the total demand, and we calculated these percentages. But we could have also said, okay, 75% of my total demand, that's 300. And then I could have probably just said, okay, I want the actual demand fulfilled within the level of service policy to be 300 or higher. With that, I would have always have talked in units, which means in boxes for this problem, and I would have not used rates. Would that have given me the right result? Of course, because I'm saying the exact same thing, just is that I'm saying in a different way. That brings us back to units. If we're talking in percentage, we just need to be sure we're talking about percentages in both sides of my inequality or equality for the constraint. If we're talking in boxes, let's always talk in boxes. If we're talking in minutes, in days, we need to keep that unit consistency. So that's also a huge advice for you for grid assignments and exams. Always keep that in mind. Always name your units, because that's going to make a difference for you whenever a problem statement asks you to consider different units and probably make some conversions so that these are consistent across your model. With that, we're ready to go. Congratulations on making it through the recitation. I hope that you have enjoyed it. If you have any questions, comments, or thoughts you want to share, please use the discussion forum. And of course, your feedback is appreciated, so I look forward to receiving it. Good luck with it, and I hope to see you at the finish line of this program.